Welcome back for part 5 of the Building Science for Dry Climates video series with Franklin Energy. In this video, we're going to discuss the building shell, air sealing, and attic insulation. Be sure to watch the other videos in the series. They're presented in a way that's meant to inform your approach to delivering affordable, comfortable, energy efficient, and safe homes for your customers. Let's start with building shell retrofit strategies. This graph from the California Energy Commission shows typical air leakage areas in homes. The attic is not separated out, but it's the largest piece of the floors, walls, and ceiling category, and combined with floors and walls, make up over a third of all air leakage. Many people think that replacing windows is crucial. According to this graph, windows come in fifth behind floors, walls, and ceilings, fireplaces, plumbing penetrations, and doors in terms of air leakage. Measures on this sample priority list are based on cost effectiveness. Most cost-effective measures are at the top of the list. Skipping measures is discouraged unless serious, unsolvable problems prevent their consideration. Notice the recommendation for closed wall and floor cavities to use the drill and frill strategy with 3.5 pounds of cellulose per cubic foot as the target density. That's when cellulose is dense enough to stop air movement inside those closed cavities and still deliver most of its rated R value. The other columns are recognizing the existence of some insulation and just prescribing the additional amount to add for the most cost-effective levels. Attic bypasses are hidden passageways for warm air to escape from your conditioned space into your attic. Some are small, but others can be quite large. Air sealing the attic floor prior to doing an attic insulation job is critical because insulation itself won't stop air from leaking out of a home. Attic hatches must be weather stripped and insulated at the same level as the attic ceiling. Pull down staircases present a special challenge since they protrude into the attic when folded. For these, you can specify a commercially available insulated cover. Most attics are easily accessible and once air sealed should be insulated to cost-effective levels for their climate zones. R38 to R44 are common levels in the Central California Valley. For attic spaces that have a floor, your ultimate R values are limited by the size or depth of the ceiling joists. But drilling a hole to blow in dense packed cellulose is a strategy that will maximize the R value for that space and serve as an air sealing measure as well. The densely packed cellulose will stop air leakage through that area. In older homes, it's not uncommon to find uninsulated walls, floors, and attics. Learning how to identify strategies to address even the troublesome areas like porches and additions is crucial to an effective air sealing and insulating retrofit. A well-done retrofit job includes the critical junctions where different building assemblies come together and where mechanical penetrations were cut to run plumbing, wiring, or ductwork. The goal is to have a continuous thermal and air barrier in contact with one another surrounding all of the conditioned. Attic knee walls can be quickly air sealed and insulated with 2-part spray foam. Spray foam provides both the needed R value, but also air seals the wall. Notice that it's critical to air seal the ceiling joist bays below the wall as well. And there's a note to consider using the bottom of the roof deck as the thermal and air barrier if knob and tube electrical service is on the floor of that attic. You just can't cover knob and tube, so spraying the bottom of the roof becomes an option to bring those knee walls inside the thermal. A floor that separates conditioned space over an unconditioned garage could be an area that allows a lot of conductive heat loss in the winter. Adding insulation and creating an effective air barrier would improve not only the R value, but the indoor air quality as well. Most of us keep stuff like paints, cleaners, other kinds of solvents in the garage so that air that infiltrates into your home from your garage can bring in those fumes and other VOCs that are down there. Cantilevered floors can also be a source of conductive heat loss if left uninsulated. A drill and fill dense packed cellulose could be an easy fix here as well. This slide reminds us to target big leaks first, rather than going after lots of little leaks. Mechanical and plumbing penetrations can be the source of large amounts of air leakage. It should be the focus of targeted air sealing measures. Other areas of interior air leakage could include old pocket doors, where there was literally two walls with the pocket door in between them, and recessed lights, which often have holes in the top of them, can allow the built up heat to escape. But unfortunately, your conditioned air can escape through those same holes too. Some common ways to prevent this is to build a box over the can or a retrofit an LED bulb that has a solid lens and an air gasket to cover the face of the light fixture where it meets the ceiling. There's quite a bit of literature written about this, but basically, you need to first identify if the existing light cans are insulation contact rated or not, because IC rated fixtures can be covered, non-IC rated fixtures cannot. Covering up a non-IC rated fixture can lead to potential fire and also reduce the life of the bulb. Drop soffits like the one seen here can also be a hidden area that allows for air leakage. A crawl space retrofit is also a good idea for uninsulated floors. Cleanup and moisture mitigation are the key parts of a good crawl space retrofit, as well as sealing ductwork and any penetrations in the floor or wall plates. There are two schools of thought when it comes to crawl space retrofits. The first being what I just described, where we seal and insulate all we can to create the best thermal and air barrier at the floor, separating the crawl space as unconditioned space under the home, and the floor becomes the pressure and thermal boundary. The other option to use is to use the perimeter foundation walls as the pressure and thermal boundary, essentially making the crawl space part of the conditioned space, where you seal and insulate the foundation walls, and now the ductwork down there is inside the conditioned space. Here are two examples, but we recommend the use of two-part spray foam. Foam is preferred because it's more dependable on keeping the walls above the dew point. Dew point is the temperature where water vapor condenses to liquid form. In summary, learning how to anticipate common air leakage sites in various types of building stock can save your company time and money with targeted air sealing for different types of building shells. Knowing the traditional types of air sealing strategies will also inform how to try new and innovative techniques and materials. And lastly, you should prioritize your air sealing and insulation strategies around those areas that will get you and your customer the most bang for the buck. Focus on the measures that will yield the most energy savings with the least amount of time and material costs. Let's focus in a little more on targeted air sealing and attic prep. Here's the pie chart again. And while there's no slide specific to attics, we know that ceilings are the largest contributor of the largest piece of pie, representing over a third of all of the shell leakage, making the floor of the attic one of the most important targets for any air sealing job. Some common leakage sites in a ceiling include recessed lights, attic access hatches, drop soffits, penetrations in the top plates, and gaps between wood framing and hot surfaces like masonry chimneys and metal flue pipes. Installers have two main goals in the attic: find and seal air leaks and prepare the attic to receive blown in or other forms of insulation. Here are some common tools and their purposes: spray foam on the top left and rigid foam board on the top right. Sheet metal for building dams around flues and chimneys. High temperature caulk for use around flues and chimneys. Utility flags to mark can lights and junction boxes so they can be found even after everything's covered in cellulose. Insulation rulers or attic rulers to monitor the depth of the insulation throughout. Zip ties and tightening tools for attaching ducts. Mastic and gloves for duct sealing. Staplers and weather stripping and tin snips for a variety of cutting and fastening things up. Do you see anything missing from the picture? I don't see a flashlight. Probably be a good idea, or a headlamp. I also don't see a dust mask or a respirator, any other kind of safety gear. Knowing where to find typical leakage areas can guide your air sealing efforts. There's tricks like using a blower door to exaggerate air leakage enough to see the air moving with smokestacks, and identifying leakage spots by the presence of dirty insulation. Some general guidelines for choosing the best materials are like using caulk on gaps up to 1/4 inch, but spray foam on gaps larger, like up to 3 inches, and using foam board or other things like fiberglass shoved into plastic bags for even larger holes. There needs to be strategies for how to deal with high temperature issues like recessed lighting and flue pipes. Having the appropriate materials and the training to do these right is key. For flue pipes, you need sheet metal to cover the area around the flue to prevent the bypass, and high temperature caulk to seal the edges. There should never be insulation over knob and tube. It's best to have an electrician change it out, today's Romex or something similar. Wiring splices should be in junction boxes marked with a flag above to make it easy to locate after the insulation is installed. The attic prep needs to include everything you intend to do prior to installing the insulation. And it should include building the dams around any potential hot surfaces, overhead flags, replacement of attic rulers. Eave vents too, to avoid covering the vents with insulation, and also verifying that you've got safe electrical service. Using technology like an infrared camera can help identify areas you might have missed, and identifying them before you insulate still gives you a chance. For the sake of time, I'm going to skip this video, but you should be aware of a lot of helpful information out there. This is the weatherization channel. You can see it on YouTube. So using tricks like blower doors or spotting dirty insulation to be a guide to help you find air leaks. Knowing some of the common air leakage areas like mechanical chases, flue, and plumbing penetrations will also help. Having access to and using the right materials will increase your productivity. Train your installers about the importance of maintaining clearances to combustible materials, recognizing unsafe wiring or other electrical issues. Lastly, to think of the next guy. Mark things like junction boxes and overhead flags so that once the insulation is installed, other technicians can have a chance to locate things beneath the insulation surface. With the attic prep complete, let's look at some options and guidelines for installing the attic insulation. This chart from the International Energy Conservation Code is intended to give us an idea of the range of cost-effective levels of insulation for our various building assemblies based on the climate zone we're in. Most of Central California is in climate zone 3, so we can see the levels of cost-effective insulation in attics are between R30 and R60. What they're indicating is that our hot, dry climate, if you don't have at least R30, your utility bills are going to be higher than they need to be. And it's also likely that saying that the extra money it would take, time and materials to insulate up to, say, R80, isn't really going to pay back itself for its investment. Most of that potential will be realized and maxed out up somewhere in between R30 and up to about as high as R60. You can follow along from left to right and see other building assemblies like cathedral ceilings at R22 to R38 and ending with floor assemblies at R25. These pictures show how important it is to use attic rulers so the installer knows how much insulation to add. Placing the rulers every 15 feet or so gives the installer a frame of reference to keep a consistent amount being blown throughout the attic. The rulers should be facing the direction that the installer will be facing as they work their way back toward the attic access hole. It's a separate thought, but I also like the use of the cardboard baffles at the bottom of the rafter bays in the picture on the left. This allows for eave vents to remain clear. I just wanted to point them out if you didn't recognize them in the picture already. Properly insulated attics should have a nice even layer of the appropriate depth of insulation and dams around high temperature surfaces and overhead flags to identify things like junction boxes, recessed lights. Spray foam is another option for insulating homes. Some things to know about spray foam is that it's typically used to provide needed air sealing as well as additional R value. It can be used in both horizontal and vertical applications, but due to fire ratings, it can't be inside the living spaces. Spray foam comes in a variety of shapes and sizes in expanding or non-expanding formulas. Product options also include one-part or two-part formulas. One-part spray foam formulas typically come in spray cans, but also can be in canisters that screw on to specialized spray nozzles. Two-part spray foam is sold in portable, pressurized tanks, or for larger jobs, they can be large truck-mounted tanks. Here, you can see the typical one-part options: the non-adjustable spray cans on the left, and the more specialized adjustable gun-type applicators on the right. One-part foam can be used to fill small holes or with a combination of other rigid materials to form a tight seal. The installer in this picture is cutting and fitting cardboard into an open stud bay and sealing the edge with one-part spray foam. The advantages of one-part spray foam is that it's quick and easy for small holes and gaps. It creates an effective seal for even small holes. Also, it's lightweight and portable, easy to take with you. Some disadvantages include long setup time, sometimes up to 2 hours. Also, it's not cost effective for larger jobs, and freshly sprayed product doesn't stick to overhead surfaces. It can even be difficult to get it to stick to vertical surfaces. A typical package of two-part spray foam includes two pressurized tanks consisting of different chemical components, Part A and Part B. When mixed in a specializing mixing tip and dispensed into the ambient air, closed cell polyurethane foam is produced. The material expands to roughly 3 times the initial volume and sets up to a hard shell cure in less than a minute. The kit also includes a hose attached to a gun type dispenser and several interchangeable standard and wide spray pattern tips. Two-part foam systems are designed as a one-time use only product. Tanks, hoses, and guns are disposed of when the tanks are empty. Quantities are stated in board foot. A 200 board foot package typically yields about 16 and a half cubic feet of coverage. The large 600 board foot kits of spray foam, like the one pictured here, come in two metal tanks that look like propane tanks for a gas grill. Larger kits are often a better value in terms of the cost per board foot of material. The weight of a larger system makes the job site maneuverability a little more difficult, but longer hoses in combination with centrally located tanks can solve that problem. A dedicated vehicle for bulk spray foam applications provides the best price per board foot. Examples of bulk application include spraying under entire floors, exposed knee walls up in attics, and crawl space foundation walls. Two-part spray foam seals irregularly sized gaps quickly and effectively. Two-part foam will fill up to about 3-inch gap with the proper application. Larger openings require some kind of backing material like unfaced fiberglass or rigid foam board. Larger holes like these require solutions like this, a combination of materials. Fitting insulation board into the large gaps, sealing edges with two-part foam is one of the easiest and most cost-effective air sealing techniques. This technician is cutting fiberglass bats into sizes that he can fold and stuff down into these open stud bays. He uses that as the backer material and then spray over with spray foam. This technique is even faster than using the cardboard block seen in the previous picture. It's also a good opportunity to point out the missing respirator. Exposure to the particles of fiberglass and the fumes associated with the spray foam are both bad for you. Protect yourself. Fiberglass backer and two-part foam were used to seal these attic stud bays. But a lot more foam was applied here than really necessary, bulging out almost a foot. Foam is expensive. Don't use more than required to get the job done. Common use of spray foam is to seal and insulate the rim of a floor system. Learning how to apply foam in a uniform pattern around irregular surfaces takes time, but installers learn how to pick the right nozzle for the spray pattern, distance the gun to the wall, and even the speed at which they move. They'll get it right. Here's another example of an attic knee wall sprayed in multiple passes, allowing each layer to cure and adding layers to achieve the desired R value. Chemical reactions during the cure cause temperatures within the product to rise, which is normal, but applying too thickly in one pass may result in excessive high temperatures. Here we see spray foam used in a basement and sprayed down 2 feet below the grade outside. Because of the steady temperature of the earth, this essentially brings the basement inside the thermal and air barrier and eliminates the need to insulate the floor. Some advantages of two-part spray foam is that it provides more thorough air sealing, reduced labor costs, and it has a quick cure time and good adhesive qualities. Some of its disadvantages are that it's expensive, it's easy to waste, and it has restrictive temperature windows of, too hot or too cold, and it doesn't spray correctly. Yeah. It also requires expensive and specialized personal protective equipment. Safe use of spray foam requires that you have an MSDS at the job site whenever spray foam is being used. Follow the precautions for safe handling and use. The MSDS lists emergency and first aid procedures. Also, use in well-ventilated areas. Provide ventilation fans to exhaust fumes and ensure cross flow and fresh air. Wear personal protection equipment like coveralls, rubber and latex gloves, and eye protection. Providing the best options for your installers would include a positive pressure supplied air respirator. A positive pressure supplied air respirators can use a mask or a hood. The replaceable lenses are inexpensive and extend the life of the equipment when the lenses get scratched or foam overspray on them. The hose can feel like a burden, but the protection you get from the fumes of the spray is unmatched by any other form of respirator and goggle options. So, a spray foam summary would include that spray foam is used primarily to air seal. Spray foam can be used to insulate crawl spaces and knee walls. One part spray foam is used for small jobs, but it's too expensive for big jobs. Two-part spray foam adheres to vertical and overhead horizontal surfaces, where one part spray foam does not. Spray foam is available in large kits and even truck-mounted systems for big jobs. Proper ventilation and respirator equipment protects workers from these harmful gases. And lastly, that because of fire ratings, foam cannot be left exposed in living areas. A summary of the larger presentation would include that when done together, insulating and air sealing attics can reduce home heating and cooling costs by up to 20%. Insulation provides the thermal envelope or boundary around the conditioned living space. To follow cost-effective guidelines to determine the target for how much insulation to install. Maintain appropriate clearances from high-temperature building components like chimneys and flue pipes. Mark electrical boxes and fixtures before insulating. Use rulers stapled to rafters or stapled up from the attic floor to measure the depth of insulation for blown-in insulation jobs. And cover every spot evenly. Thank you, and I hope you join us for the other videos in the Building Science for Dry Climates video series.